Welcome to the Reflection and Refraction video. In exercise 1, we'll be bouncing a single light ray off of a flat mirror to test the law of refraction.
Connect the power adapter to the light source, plug it in, and set it to a single ray.
Place the mirror on a sheet of blank paper and trace around it.
Draw a dashed line perpendicular to the flat side.
Replace the mirror and align the light source such that the ray points at the intersection of the flat side and the dashed line. Trace the input ray. You may find it helpful to remove the mirror during this. Replace the mirror again and trace the reflected ray.
Draw arrows on the incident and reflected rays and label them. Use the protractor to measure the angles of incidence and reflection.
Repeat this process for at least 8 different incident angles. If your page is getting cluttered, you can use multiple pages.
In exercise 2, we'll be comparing the focal length and the radius of curvature of a concave mirror.
Once again, place the mirror on a sheet of blank paper. Set the light source to emit 5 rays and aim it towards the concave side of the mirror.
Dim the room lights and arrange the light source so that the center ray is hitting the mirror at 90 degrees. Trace all 5 input rays. It may be helpful to remove the mirror while doing this. Replace the mirror and trace the reflected rays. It may be necessary to mark points and connect them or move the light source so there's more space.
In exercise 3, we'll be comparing the focal length and radius of curvature of a convex mirror.
Yet again, place the mirror on a blank sheet of paper and trace it. Place the light source such that the center ray makes a 90-degree angle with the mirror. As before, trace the input and reflected rays. Draw arrows on the rays to indicate the direction of travel. Extend the rays with dashed lines to find their intersection.
In exercise 4, we'll be investigating Snell's law of refraction using a prism.
Place the prism on a piece of blank paper and trace it. Send a single ray into the prism at a 45-degree angle as shown. Trace and label the input and output rays, then remove the prism and connect them.
Add a dashed perpendicular line at each interface and measure the angles of incidence and refraction at each. Repeat this process at several different incident angles, covering as wide a range as possible. Collect enough points to make a graph, and as before, feel free to use more paper if your page is getting cluttered. Thanks for watching the Reflection and Refraction video, and if you can figure it out, please tell us. If vampires have no reflection, how come they have such neat hair?